This is lesson 1.3. It's titled For the Birds, and it's about ratios, rates, and proportions. So in this lesson, you will write ratios and rates, you'll write proportions, and you will scale up and scale down proportions. The key term that you need to update in your vocabulary section is simply the word convert. Which bird lays the largest egg for its size? That honor goes to the little spotted kiwi, a native of New Zealand with no tail, a very long ivory beak, and poor eyesight. The little spotted kiwi lays an egg that is more than 1/4 its own body weight. By contrast, the bird that lays the smallest egg for its size is, you guessed it, the ostrich. Perhaps you didn't guess that. Although ostriches lay the largest eggs, a typical ostrich egg weighs less than 15/1000th of its mother's weight. Why do you think that the ostrich egg is both the largest egg that any bird lays, but also the smallest egg in comparison to its mother's weight? So that's something to think about as we get into this investigation or this lesson. Okay, the table shows the weights of 4 different adult birds and the weights of their eggs. It says compare the weights of the eggs, list the birds in order from the bird with the largest egg to the bird with the smallest egg. Take a few seconds and then unpause the video, check your answer. Hopefully you got those answers okay. Number 2 says determine the ratio of egg weight to mother's egg weight. Determine the ratio of egg weight to mother's weight for each bird. Use your calculator to help you. Write the ratios as decimals. The key when thinking about this ratio is it says egg weight to mother's weight. So that means for each case, you're going to write the number for the egg weight first, and then the number for the mother's weight second or below the egg weight. So let's talk about the first one. The first one would be pigeon. The egg weight for the pigeon is 0.75. I'm going to write these in fraction form for now. So it's 0.75, and then the mother's weight is 10. This asks us to use our calculator to write the ratios as decimals. So I would simply put 0.75 divided by 10, and that would give me a decimal weight of, or ratio of 0.075 ounces. Next we have chicken. The egg weight for a chicken is 2 ounces over, I guess I should label these, over the mother's weight, which is 80. So I can simplify this fraction to 1/40. If I put that in my calculator, I would have 1 divided by 40, which gives me a decimal of 0.025, and that's ounces. The swan comes next. I want you to go ahead, pause the video, complete the last 2, and then come back and check yourself. Okay, so hopefully you have the same decimal ratios as I do. We're going to move on to number 3. Number 3 says use your decimal representations to answer each question. Explain your reasoning. So which of the birds listed lays the largest egg for its size? So we're going to kind of come back and forth on this one. So the largest egg for its size. Whoops. So if we look back on this slide, we can see the largest egg for its size would have to come from the pigeon, because 0.075 is greater than any of the other decimal forms that we have. So That first one would be pigeon. Of the birds listed, the pigeon has the greatest ratio of egg weight to mother's weight. So I want you to try B and C and then come back and check yourself. Okay, so go ahead and check yourself. Hopefully you're on the right track with that. Let's go ahead and move on to problem 2. The coyote and the ostrich. Although the ostrich is the largest living bird, it is also the fastest runner. The table shows distances that 4 birds ran and the amount of time it took each bird to run that distance. So we have an ostrich that covered 22 miles in 30 minutes, roadrunner 300 yards in 30 seconds, quail 20 yards in 2.5 seconds, and a pheasant with 200 yards in 50 seconds. Each row in the table shows a rate. The rate for each bird in this situation is the distance covered per the amount of time. So the rate or running speed for the ostrich is 22 miles per 30 minutes, or 22 over 30, which hopefully that's pretty standard, so explanatory. So write the rate for the other 3 birds. Well, if we check the table, we go back up to the table, it says we want the rate of distance over time frame. So for that first one, we could say 300 yards per 30 seconds, which written as a fraction looks like this. I want you to try the other 2 and come back on when you're ready to check. Alright, hopefully you're on track with those. So we're going to go ahead and move on. The next section has another table for us to analyze or to look at. There are many situations in which you need to convert measurements to different units. To convert a measurement means to change it to an equivalent measurement in different units. Converting measurements can help you compare rates. When the units of the measure are the same, you can more easily compare the rates. So the table below shows some common measurement conversions. These are some that you should already be familiar with. Maybe not weight, but these are also helpful. Capacity, and then we have time. The time ones you should be familiar with as well. So let's move down here. You can use the table of common measurements as rates to change one measurement to an equivalent measurement in different units. So write each length in the table as a rate. So for this first one, 12 inches equals 1 foot. So 12 inches per 1 foot, or 12 over 1. The same thing for this one. This one should read 60 seconds per minute, or simply 60 seconds over 1 minute. So I want you to continue. Do B through D for each different set. So in set 2, you're going to write each length in the table as a rate. And then for 3, you're writing each amount of time in the table as a rate, following the same process for both sets. Then come back and check yourself. You can convert the running speed of the ostrich from being represented in miles per minute to show the units in miles per hour. So you know the ostrich ran 22 miles in 30 minutes. You can use a proportion to describe the ostrich's speed in miles per hour. So basically, we know that 30 minutes times 2, it gives us 60 minutes, which is represented right here. And what I do to my denominator, I have to do to my numerator. So I would take my 22 right here, multiply by 2 again to get what, how fast or how many miles the ostrich would run in 60 minutes. So 22 times 2 gives me 44, and then that 30 minutes times 2 gives me my 60 minutes. So I can now say that the ostrich's speed is 44 miles per hour because I know 60 minutes is 1 hour. So that's that's the conversion there. So 60 minutes is 1 hour, and so I can scale it up to see its speed, or its miles per hour. You can also use the unit rate of 60 minutes over 1 hour to convert the ostrich's speed from miles per minute to miles per hour, which is basically what we just talked about. So basically this is representing the same situation. So the ostrich's speed is 44 miles per hour. They just did some converting here because we have minutes over minutes, and when you have two of the same unit over top each other, they cancel each other out. That's why they marked through them. So 22 times 2 still gives me that 44, and then we have our 1 hour in the denominator. You can scale up the rate for the Roadrunner to describe its speed in miles per hour. So again, they're doing the same thing. We know that 30 seconds, if we wanted to scale it up by multiplying by 120, that would give us our 3,600 seconds, and then 300 times that 120 would give us the 36,000 yards. So the equivalent would be the 20.5 miles per hour. We multiplied this 30 by 120 because we know that there are 3,600 seconds in 1 hour. So again, we're trying to get that unit rate. We're trying to see how far they would run in 1 hour. So if I multiply by 120 on my denominator, I have to do the same thing on my numerator. So in order to get that 1 hour on the denominator, I have to multiply by 120. So then there again, I would have to do 300 by the 120 to get the 36,000 yards that this Roadrunner would run. So then the equivalent would be, if we converted the yards to miles, I would have to divide by 1760 to get the 20.5. So basically 36,000 divided by 1,760 would give you that approximation of 20.5 miles per hour that the Roadrunner would be running. You can use a unit rate to convert the Roadrunner's speed to miles per hour again, doing the same thing as we saw previously, to end up getting that 20.5 miles per hour. Write a proportion or use rates to determine the quail's and pheasant's speeds in miles per hour. Use your calculator to help you. So I'm going to walk you through the one using quail, and from there you're going to do pheasant on your own. So we know that we have 20 yards in 2.5 seconds. If I wanted to write a ratio that's going to be equivalent, we got to figure out how many seconds we need to have total in order to get that 1 hour. So just like in that previous problem, we know that 3,600 seconds gives me a total of an hour. So now we have to figure out what are we multiplying here to go here? What do I need to multiply 2.5 by to get a total of 3,600? Well, the way that you would problem solve that is you could take your 3,600, divide by 2.5, and you'll see that it's 1,440. So if I multiply the top by 1,440, I'm going to have to multiply, the bottom by that, then I have to do the same with my numerators. So if I take 1,440 and multiply by 20, that would give me a total of 28,800. So these two create a proportion because they are equivalent fractions. So now, based on the prior problems that we did, we know that there are 1,760 yards in a mile. So I can take my total of 28,800 divided by 1,760 yards, and that will give me 16.4 miles per hour. So again, all I did was I took this. I know that this equals 1 hour, so I'm good with my units of time. I'm taking my total yards and I'm figuring out how many miles are within this total yard. So I know that 1 mile equals 1,760 yards, so I can take the total number of yards that I have, divide by that 1,760, and that will give me how many miles total. And then I know that it's already has the hours underneath it from this right here. So why don't you go ahead and try the pheasant speed and then come back and see if you're correct. So on this one, I had to multiply by 72 to get this. So that therefore I had to multiply by 72 to get this one. From there, I would say my 14,400 divided by that 1760 from our conversion that we talked about earlier would give me an approximation of 8.2 miles per hour. So opposite from scaling up, sometimes it's easier to scale down ratios to figure out certain things that you're asked of. So write the birds in order from fastest run to the slowest run. So in this case, they're scaling down. So in scaling down, you are dividing by something instead of multiplying. So with scaling up, you multiply by the same term, both numerator and denominator. In scaling down, you're going to divide by the same term, both numerator and denominator. In this case, they're dividing by 30 so that they could figure out the distance this ostrich ran in 1 minute. So 30 divided by 30 gives me my 1. 22 divided by 30 is going to give me that 0.73 for my miles. So actually, there is a typo in your book. This should not say minutes. That should say miles, if you want to go ahead and correct that in your book. Go ahead and come up with the order you think the fastest run to the slowest run in is, and then check your answer. Okay, so scale each common measurement up or down to determine the unknown quantity. So I'm going to go ahead, I'll do a couple with you, and then I want you to finish this and check yourself. So for instance, let's do number 1. So 12 times something gives me 48. So 12, 24, 36, 48, it's multiplied by 4. So then therefore I have to multiply by 4 down here to get a total of 4 for the missing term that I'm supposed to fill in right here. You could also, to figure out 4, you could do 48 divided by 12, which gave me 4, and then that means if I divide by 4 to get 12, then I'm multiplying by 4 to get 48. So that's another way that you can problem solve. And don't forget your units. Let's try one more. 1 times 4 is 4, so 3 times 4 gives me 12, which is the missing term here. Go ahead and complete this page, come back and check yourself. Okay, in this very last section, we're going to use a rate and multiply to determine each measurement conversion. So how many quarts are in 12 cups? Well, you should know, or maybe you don't, but you can look back in your table that 1 quart is 4 cups. So 1 quart is 4 cups. Right now we have 12 cups. So we can use this and what we know to see that we have actually 12 over 4, which is 3. So this is going to be quarts. So there are 3 quarts in 12 cups. So I want you to try B, C, D, and E, and then come back and check yourself. Okay, so this concludes 1.3. If you have any further questions, make sure you come and see me, and we can do some small groups if need be. But at this point, if you're comfortable, I'd like you to go ahead and do 1.3 skills practice.